Okay, and then lastly from chapter 5, we included problems such as find all of the zeros. And this was a combination of sections 5.6 and 5.7, where we talked about our fundamental theorem of algebra, which says that if you've got an x cubed, you should be on the lookout for 3 solutions for x, given that if you have something that counts double, you count it double, etc., etc. When we had these problems, we always started first by considering our possible rational zeros. And remember, those were your p's over your q's. So all of the factors of your constant at the end are your p's. So lucky for us, it's just 1 and 3, plus or minus for both. Those are your p's divided by your q's. Those are all of your factors of your leading coefficient. So plus or minus 1, plus or minus 2. Now remember that if your goal is to find all the zeros, you don't have to go through and talk about each separate fraction. I'm going to go ahead and do so for a nice reminder. So when you've got plus or minus 1, plus or minus 3 over plus or minus 1, plus or minus 2, remember you're considering every single combination. So 1 over 1 would just be 1. And then 1 over 2, you've got 1/2. Then you've got 3 over 1, which would just be 3. And lastly, you've got 3 over 2 plus or minus 3/2. Now, obviously, already we're up to 8, and we said we should expect 3 zeros. That's why we call them the possible rational zeros. These are not all of our options. But we're going to start here when we synthetically divide. Remember, we always like to start with positive and negative 1 and hope and pray that one of them works. If not, we go to our graphing calculator and pull up a graph. So let's just try positive 1. We're going to do synthetic division just like we did in our last problem. So across the top, we will have x cubed, x squared, x in our constant. And our coefficients are 2x cubed, 3x squared, negative 8x, and a constant of 3. Bring down your 2 and multiply, add and multiply, add and multiply. Thank goodness, 1 was a solution because we got a remainder of 0. So this is when I would kind of like keep track of all of my zeros. So we just said that x equals 1 works. So don't forget about that guy. But now what we're left with, 2x squared plus 5x minus 3, we are able to solve maybe by factoring, but at the very least by using our quadratic formula. So since we won't always have ones that factor, I believe this one will, but let's go ahead and use the quadratic formula for this guy just for another refresher. So we'll have x equals negative 5 plus or minus the square root of b squared minus 4 times 2 times negative 3 all over 2a. So we continue to simplify. X equals negative 5 plus or minus the square root of 25, and then again we've got a negative times a negative. So 4 times 2 would give us 8 times 3 is 24. 25 plus 24 under our radical is 49. That's great news. All over 4. Square root of 49 is 7. So sure enough, that guy was able to be factored because we've got 2 nice looking answers. We've got negative 5 plus 7 over 4 and negative 5 minus 7 over 4. Negative 5 plus 7, we get 2 divided by 4 is 1/2. Negative 5 minus 7 is negative 12 divided by 4 would be negative 3. So we add those to our box. All of our solutions include 1, 1/2, and negative 3.